Hello, we're back with question 2 on the myimaths task. Okay, so for each of these functions, find the stationary point and determine whether they are maximum or minimum points. So, let's start with question 2 here. 9 minus x squared. We have to find the gradient function as usual. Gradient function is minus 8. We drop off the x and bring down the 2, so minus 8 minus 2x, just like the previous videos. We need to find the x-coordinate when this equals 0. Again, we let the gradient function equal 0. We solve for x. Add 8 to both sides, divide by minus 2. So, the stationary point is going to be found at x equals minus 4, the x-coordinate of the stationary point. For the coordinate, we substitute back into the original function. And if you do the math here, you'll end up with 9 plus 32 minus 16. This is a tricky one. We have to do minus 4 squared first, and then take that away. So minus 4 squared is actually 16, and then we take away 16. So y equals 25. Our stationary point is found at the coordinate minus 4, 25. Now let's look at the graph. I have for you here the graph of this function. Because I graphed it, we can clearly see this is going to be a maximum point. However, how would you do it without the graph? Without the graph, for a quadratic, whatever the coefficient of x squared is will tell you the direction, or what we say is concavity, of this function. This one's facing down, or concave down. If this number is negative, it will be a maximum. If the number in front of x squared is positive, it will be a minimum in a quadratic. That's how you can figure it out for a quadratic, a max or min. Okay? The next one I would like to try, I believe, is number 4. Let's have a look. There it is. Number 4, we have x cubed plus 3x squared plus 2. Now this one is going to be a cubic. It's going to be a different shape. But let's first do what we have to do. In a cubic, there's actually going to be 2 stationary points. Okay? The higher you go, the more stationary points. In a cubic, it's going to be 2. So first we find the derivative. Bring down the 3 and take away 1 from the exponent. So that's 3x squared plus 2 times 3 is 6 times x. And the 2 drops off. So we end up with 3x squared plus 6x. That's our derivative. Where is the gradient 0? Well, we need to set our gradient function equal to 0. 3x squared plus 6x equals 0. Here we're going to have 2 answers. Recall that when you have a quadratic and you're trying to solve a quadratic, you have 2 answers. So we have to factorize first. Let's factorize out the x and the 3. So we end up with 3x times all times x plus 2. After we factorize, we can figure out which values of x will make this equal to 0. The first one in 3x, 0 will make that equal to 0. So in the first, x is equal to 0, because 0 times anything is 0. The second value of x that will make this 0 is minus 2, because minus 2 plus 2 is 0. So these are the 2 values of x where you will find our stationary point. Now we have to find the corresponding y-coordinates. So for the corresponding y-coordinates, we sub 0 in to get y1. y1 will be simply 2, because 0 plus 0 plus 2 is 2. And for the second value of y that corresponds to our x value of minus 6, substitute, this should be minus 6 in, okay? Oh, it's not minus 6. It's minus 2. Substitute minus 2 in, okay? This is where it's wrong. Substitute minus 2 in, we get 8 plus 4 times 3 is 12, plus 2. So we have minus 8 plus 12 plus 2, and that gives us 6. Remember, this is minus 2 cubed, so minus 2 times minus 2 is 4, and then 4 times minus 2 is minus 8. Alright, now that we have our coordinates are 0, 2, and minus 2. This should be minus 2. And 6, minus 2 and 6. Let's go to the graph. So here it is. This is the graph we're talking about. Now here you can see that the stationary points are at minus 2, 6 and 0, 2. That's where our gradient is equal to 0. If you didn't have the graph, how would you figure out if they're maximums or minimums? Well, you'd have to do a little investigative work, okay? Maximums occur when the gradient is very, very positive, goes to 0, and then turns to negative. So I'm going to put minus 3 into our gradient function. If I put minus 3 in, I'm going to find out what the gradient is before our maximum. So if I substitute minus 3 in here, I will get 9. That is a positive value. Then just after the gradient, just after the stationary point, I'm going to substitute the value of x equals 1 to see what the gradient gives me there. If I substitute minus 1, and I substitute it into the gradient function, I will get a value of minus 3. That's a negative gradient. So I'm going from a positive gradient to a negative gradient. The only way that can happen is if I have a maximum point to go from positive to negative. So this one is a maximum point. If I substitute 1, you can see that I'm going to get a positive value for the gradient. So this is going from negative to positive, so it has to be a local minimum. So I've got a local maximum and a local minimum. That's how you can figure it out without the graph. So, if you'd like, you can try the other ones, number 1 and number 3. Pause the video and try those. And here come the answers. Thank you, and good luck with your myimaths tasks.